Welcome to vlog 52. This is Business Math 135, fun with Excel and math. Hey, we're still in chapter 10. We're talking about future value. Man, isn't this exciting? We get to figure out how much we are going to have when we retire. Let's go to our next sheet tab, FV2. If you want to be a millionaire in 35 years and can earn 12% compounded monthly, how much do you need to deposit at the end of each month? Well, let's see. Millionaire, that's in the future, we know. And we got a bunch of years and interest rates. How much do you deposit at the end of each month? Whoa! Hey, depositing at the end of each month, it seems like equal payments and the time interval between them are equal, so it sounds like an annuity. Let's go ahead and list our variables. Let's see, we know future value, that's what we want, millionaire. Why wait that long when you could go on one of those TV shows? Ooh, that's 10 million. We could do that one too, but we're only going to do a million. Let's see, years. Notice how when I write down the variables, and I always do this, I just start at the beginning and go through slowly and don't skip over anything. Let's see, millionaire, that's future value. Years, that's going to be years, 35. That's not it. That's annual rate. Delete. Oh, there it is. B10. So that's 35. 12% compounded monthly. So the 12% is the annual rate. Notice it's pre-formatted so that little percent comes up. Compounded monthly. Let's see, and it also says each month. So that means this is a month period. So the number of compounding periods per year, 12. How much do you deposit at the end of each month? Man, I can't wait to find this out. This is exciting. Sounds like the payment. So that's going to be question mark. Ding, 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 ding. All right, and this is at the end of each month, so I'm going to come down here, and Excel makes it easy. I hope some of you look at the PDF and see how you have to alter that formula. It gets pretty, lots of steps. But here we just have a 0, 1. 0 is for ordinary, 1 is for annuity due. Hey, this is at the end of each month, so we're going to put 0. Now let's come down here, and we need to think about this a bit. We've seen future value and present value. And we need to see if there is a function that will calculate the payment. So let's go, I'm going to click in the cell, and let's go up to Insert Function. And this is a good skill to have because pretty much any quantitative calculation you're going to do, whether in finance or accounting or statistics or any math class or sales or whatever it might be, there's probably a function here that will make your life a lot easier. So let's one way to do it is just to think payment, right? You could let's just type in the word payment. You could also just look through, go to all, and look in the P's, right? So if I scroll down to the P's, scroll down to the P's. I bet you could find something payment and then look through there, percentile, Pearson pay. I don't see a payment. And if you didn't know that it was PMT, that's kind of the universal symbol for that. You might skip over that one. You might just try them. But let's go ahead and try this version too. In fact, if I was desperate in trying to find something, I would look through all the P's and I would find it that way. But here I'm just going to say, how about just the word payment? You could also type in future value payment or retirement payment. Right? If you didn't know the fancy words, but you know this was retirement payment, click go. You would see a bunch of functions here it would suggest, and you'd have to look through and read them. NPR returns the number of periods for an investment. Well, we're not looking for number of periods. Click on this one, IPMT. Returns the interest payment for a given period for the investment based on periodic constant payments. Well, interest payment is not what we're looking for. Let's click on this next one, PMT. Calculates the payment for a loan based on constant payments and a constant interest rate. Well, this one sounds good, and it's not always a loan. Remember, one person's loan is another person's asset or investment. For us, we are actually putting money into, for us, what is an investment. For the bank, though, they're taking out as a loan from us. We might click on the next one too to see what that says. Returns the payment for the principal for a given interest. Well, principal, that sounds like breaking apart principal and interest into two parts, and we're not doing that. So this is the best one. Let's go ahead and click OK. And in fact, it is. It's PMT. It's the universal symbol for periodic payment. Now let's go ahead and read our. These are all the same. Can you believe it? Rate, NPR, PV, FV, and type. That's incredible. So there's these actually 4 very famous functions: present value, future value, and then the payment for each one of those. And this payment function can be used both for present value and future value. Let's go ahead and get our rate, which is our. Oh, we didn't calculate that yet. So I'm going to click cancel. We're going to come back here and we're going to calculate it. Equals the annual rate divided by 12. Enter. Total number of periods equals 12. That's the number of compounding periods per year times that 35. Enter. Now we can come down here, and now I'm going to show you a cool trick. If you know what the function name is, you type equals PMT, open parentheses. And I don't know where this keyboard shortcut came from, but you know, if you always do average or payment or future value and you like to use the functions argument dialog box, Control A at this point. Again, it has equal, the name of the function, and as soon as the parentheses open, if you Control A, which is usually select all, it opens up the functions argument dialog box. And a lot of people like to do it that way because it's faster to type it if you know what it is than to go and search for it. And then this dialog box is always handy. Let's click on our period rate. Tab. NPR is total number of periods. Tab. Present value. We do not have a present value here. We have a future value. Tab. The future value is, and we're going to put a minus. Actually, let's not put a minus, and let's just see what happens here. Click O. Well, you can already see it comes out minus, and the reason why is because it knows these functions. These are famous functions. These go way back in history. The first time value of money functions are like the 12th century. They're attributed to the mathematician Fibonacci. Long time. But get this, these functions are so cool. They know cash flow. Guess what? Every month you're making this payment to have this positive number in your pocket when you retire. So actually that's why it comes out minus there. Click OK. So it comes out minus because it knows that it is money coming out of your wallet into the bank. Now, if you want to make it pretty, which people mostly do when they do this, you could either put the minus in front of the future value like we have been doing, so we'll continue with that trend right there. Now, we forgot one thing, so watch this. I'm going to click up here, and the nice thing about the screen tip right here is if you put your cursor there or in this cell right here, whoop, you can see it's waiting. It knows that your cursor is touching the cell reference, so that's future value. But we forgot one thing, comma, the type. Notice what happens when you type a comma, then the bold comes up here, and we click there. Enter. That's it, $155.50 in the bank at the end of each month. Again, the variable that really makes your retirement larger is not interest rate or amount of payment, it's years. So start early and save regularly. 35 years, 155, and we get our 1 million. Let's look at our stating our answers in Word. If you want to be a millionaire in 35 years and you can earn 12% compounded monthly, you would need to deposit $155.50 at the end of each month. Man, that's cool. Let's go do our next example. If you could save $200 at the beginning of each month. They're not going to trick us. We know beginning of each month. That sounds like the other type of annuity, and you can go back and read. If you forget what it's called, you look it up, and it's annuity due. We know here that instead of a 0, because we've been doing our ordinaries, we're going to put a 1. Okay, so beginning of each month, we put this 200. For the next 35 years, we're going to 12% compounded monthly. How much will we have when we retire? Notice, this is exactly like our first problem, except for at the beginning of the month. And there's going to be a stunning conclusion when we see here putting $200. 1 month earlier will have an unbelievable impact on what we get when we retire. All right, let's list our variables. We are trying to calculate future value, so I'm going to put question marks here, if I can find it. Present value, we don't have that, so we will skip. And look, we're going to save $200 at the beginning. Again, this is the begin. And we're going to see a big difference between begin and end just by putting money in 1 month earlier. We're going to get a lot more money at the end. So PMT looks like is going to be $200. We know that. So we click here, $200. It says beginning there, so I'm just going to come right down here. Ordinary, annuity due, that's the begin one. So I'm going to put a 1 here. Of each month for the next 35 years. So years is 35. By the way, on this, in a financial calculator, the other way that people do these kind of calculations, there's a button you hit, and it's either begin or end. But in Excel, it's a 1 or a 0. Okay, so we have 35 years, and you can earn 12% compounded annual, so put that there. Compounded monthly, I mean. So the periods per year will be 12. And then how much will you have when you retire? That's the future value. Hey, let's come down here and calculate this. Equals FV, and we're just going to use that, and the screen tip. The rate, we're getting used to this by now, and look at that. I forgot it again. The period rate, we better do this, equals the annual rate divided by the number of compounding periods per year. Enter. Total number of periods equals our number of compounding periods per year times the years. Enter, enter, enter. Let's do our future value. Our rate, that's our period rate, comma, NPER, we're getting used to this by now. This is 2 chapters at least in a row we've done this. NPER is total number of periods, comma, here's where we do our payment. And I'm going to put minus because this is money coming out of our pocket, comma, present value. We don't have any present value, but we could. If we threw some in, we'd just put it there and it would calculate it for us. We're going to skip this one. Don't forget to type an extra comma. Don't forget it, because you want to see type in bold, and then click on the 1. Close parentheses and enter. We're going to go ahead and scroll down and see something pretty cool here. Now, let's just look at this. $1,299,053.81. Let's go back to our sheet tab FV1. $1,286,000. So I want to bring this number and take this number and subtract it from this number and find out the difference. Now, this is going to involve a sheet reference. So what we do is we're going to say equals this minus, and then we're going to have to click on this sheet tab, click on the cell, and hit enter. So you ready? We're going to do a sheet reference. Equals, that's just a regular cell reference, minus, and now in order to get a cell from a different sheet, you got to click on the sheet first. So I'm going to click on this FV1. Notice our formula both here. Well, you can't see it over there because it's over there, but you can see it up here. Look, it put the name of the sheet tab and an explanation point, because that means it's a sheet reference. But look, that's just a sheet reference. That would totally not work. So now we got to click on the cell we want. Notice all we had to do to get a cell in a different sheet was click on the sheet and then click on the cell. Now here's the big important factor. Do not click back on the other sheet. You got to hit enter while you're in the other sheet. Enter. Woohoo! Let's click back on this and look up here. Actually, you could have hit Control Enter too. There it is. Please take B19 1 above or 2 above and then subtract whatever's in B19 on the sheet tab FV1. You got to be kidding me. $12,000. That's just from depositing $200 1 month early. Look at that. Let's come down here and read our conclusion. If you could save $200 at the beginning of each month for the next 35 years, you can earn 12% compound amount. You'll have $1,299,053.81 when you retire. But the big thing we want to see here with the begin annuity is that just that $200 1 month early, sitting in there all that time, accruing all that interest. That's the difference. Pretty amazing. All right, let's do our next future value calculation. If your employer will match your retirement saving plan, if your employer will match your retirement savings plan monthly contribution of $225 at the end of each month. And you can, oh, that's great. That means they're going to match, right? So you put in $225, they put in $225. And you can earn 9% compounded monthly for the next 25 years. How much do you have when you retire? How much did you contribute total, and what is the total gain for you? All right, let's go ahead and calculate, or put our variables down here. If your employer will match, notice what I did is I put employer doubles it, so I put a 2. Your retirement plan, $225. So we are going to deposit from our check $225, so I put that there. Now, that means the total payment is going to be each month into your account equals the $225 times the 2. And we can go ahead and round this round, because this we're going to use later in some kind of calculation, and this is to the penny, comma 2. Now you don't need to do it here because these are two whole numbers we are multiplying, but just in case we change this to some fraction and we get two fractions, two decimals there, and then hit enter. All right, and we can earn 9% compounded monthly. So 9% is the annual rate. Ooh, that didn't work. My number. Ooh, I hit the 9 on the number keypad and didn't work. That because my numlock key was not on. Now I'm going to hit 9 and it works, and the percentage symbol comes up because it's pre-formatted. Number of compounding periods, 12. Years, let's see, 9% compounded monthly for the next 25 years. So I'm going to put 25. How much we have when you retire? Oh, future value. Wow. How much did, okay, and then we'll do those two questions. I'm actually going to put, I actually put those right here. How much did you contribute in total? Again, I like to put all the details and variables, just list them out. You know, sometimes when I actually see it and then type it down here, it helps me, you know, assimilate what we're trying to do here in this problem. So how much did you contribute in total? I put that here. And then what is the total gain for you? Question mark, question mark. So we have three things to answer. All right, let's calculate our future value. Equals FV. And our rate, our period rate, hopefully I have calculated it. There it is, 0.0075. Comma, and notice how the bold moves to NPER. That's 300 total months. 25 times 12. Comma, the payment, here it is, and we're going to put minus, because this is coming out of our wallet. Cash flow minus out of our wallet. Later, it's going to pop out positive. That's why the whole thing will be positive. Comma, we don't have a present value. Comma, type. This is, as it says up here, end, so it's a 0. Close parentheses. All right, 504,000. Now, how much did you contribute in total? Now, you got to think about this a little bit, but it's not that hard. Every month, you had $225 coming out of your pocket. So this is what you put in. Your employer matched it, right? But you actually just put $225. So here, how much did you contribute in total? I'm going to say equals C7. This is wrong here, but 225 times our 300, and then enter. Wow, you got to be kidding. That's all I put in over the 25 years? 67,500. Let's just figure out what the total gain is. Equals this total amount minus this. That is cool. So, matched plan like that is pretty excellent. And actually, double this would be 130,000, and still, even with the employer's match, if you subtract that, it's still a huge amount of interest. But here, since you only put in 225, I'm going to delete that right there because that's not right. It actually should be right. We'll scoop this out. Watch this. You come up here because you can copy it, Control C, and then hit Enter, and then come over here and space. Because if I just pasted it, it would be a formula. But if I put a space, then the equal sign is not the first character in the cell. Very good. And then let's state our answers in a word. If you can save $450 at the end of each month for the next 25 years, and you can earn 9% compounded monthly, you will have $504,504.87 when you retire. The amount you contribute is $67,500, which results in a total gain of $437,004.87. Hey, when we come back on our next vlog, we will do our present value calculations.